All right, good afternoon, everybody. We're going to go ahead and get started. I am very excited to introduce you to Seth Clark, who is head of product here at Modzy, and he is going to kick things off with an introduction. Seth, over to you.
Kirsten, thanks so much. Everyone, welcome. Thanks for joining us today. Really excited to have such a great turnout for our discussion on model retraining and model governance, an extension of a look we've been doing into the field of machine learning operations, or ML Ops. And I think today's going to be a fun discussion on some topics that don't often get a lot of coverage. We'll be going into some of the challenges with ensuring that AI models remain relevant, including how to tailor AI models to new challenges, new data sets, through an approach called retraining. We'll also discuss in general why it's a good idea to start thinking about the establishment of governance protocols in the way that your organizations are using and deploying AI at scale. Now, a lot of conversations about machine learning operations, I'll use ML Ops for short for the rest of the talk today, they tend to focus on the technical mechanics of what it takes to take Python code and transition that code into a live model in production. Tends to be very technical and focused on some of the transitions that have happened in the field of DevOps and how they apply to machine learning. In some of our past webinars, we've talked about those more technical topics, but today we wanted to focus on two key components of ML Ops that often don't get quite as much attention: governance and model retraining. By giving these topics the time they deserve, you'll be able to really improve a few aspects of how you might be scaling AI inside your enterprise. One is to help manage risks associated with shadow AI. That's essentially the prevalence of AI capabilities that start to pop up across a big company or big organization without the CTO or CIO knowing about them. To get some insights into performance of your models and what actions you might need to take to ensure that performance is where it needs to be. Help with managing costs and infrastructure usage. The scale of these AI models can be pretty significant. The resources they need to keep running are a lot higher than other traditional cloud services. And really most importantly, help enable teams to move more quickly and safely as they build out new AI-powered applications. In addition to providing some of these lessons learned and some really great insights from our guests who I'll introduce in just a moment, we'll also tell you about a few of the things that we've been doing at Modzy to build features to help you address these different challenges. Now, I am pleased to introduce you to Kathleen Walch and Schmelzer, principal analysts from Cognilytica. They're going to tell you a little bit more about this field of machine learning operations, ML Ops, and some of the insights that they've discovered in one of their recent reports. If you've not seen their report on ML Ops, I really highly encourage you to check it out. They've got some great insights. They're terrific analysts. They do a lot of research across both U.S. federal government, commercial, domestic, international use cases and agencies. Just some really good general knowledge that I look to them for across the board. And finally, just one last suggestion: if you have a question, please don't hesitate to submit your questions via the chat on the sidebar of our WebEx or Zoom meeting. That is, we'll be taking those questions and trying to address some of them during the conversation today. So I'd love to pass it over to Ron and Kathleen. Ron and Kathleen, are we the mute issue?
Oh yeah, we're good to go here.
Yes, hello everyone.
All right. Thank you.
All right, thanks Seth for introducing us, and we're very excited to be here today.
Yes, and thank you very much. We're really thrilled to have you participants. Many of you, of course, are attending virtually, and we are hopeful to feed you virtually in your mind here and get things going. So as we get that first slide up on the screen, we could tell you a little bit about our perspectives and the perspectives on DevOps and ML Ops, and of course, really this big movement towards ML Ops. So let's advance to the next slide here.
Great. So, we wanted to start the conversation today by framing what exactly is ML Ops and why is it important, and, why should your organization or agency be thinking about this? It's a fairly new term that's been around for the past year or so. And I think that there's, the term is still getting its definition in full. And that's why it was important to kind of frame around that. So as organizations move their AI projects out of the lab and into production across multiple business units and functions, the processes by which models are created, operationalized, managed, governed, and versioned need to be made reliable and predictable as the processes by which traditional application development is managed. In addition, as the markets from AI shift from those relatively, few leading organizations that have the technical expertise required to build models from scratch, many enterprises, organizations, and government agencies are going to be looking to consume models that are built by others, and rather than building them in-house on their own, because they might not have the resources available, expertise as well. So they're going to be moving more towards that, consuming rather than building. And with that, the focus shifts from tooling and platforms focused solely on model development to tools and platforms focused on overall usage, consumption, and management of models.
Yes. And one of the interesting things about ML Ops is that it builds upon a much longer history of DevOps. And we can advance the slide to the next one. And the whole idea of DevOps is that it has taught us over the last decade plus that we can instill regular processes and practices and tools and technologies within our organizations to make the production and deployment and management of all of our IT assets much more reliable and predictable, right? And that's the thing that DevOps has informed us, is that if we can standardize our methods, we can move towards things like continuous integration and continuous test and rapid deployment, and we can have predictable, code, and we can have all this stuff, which allows us to move on much more iterative cycles, which of course maps really well to the idea of agile methodologies, which is we were in love with to make that work. The challenge though is that we can't apply DevOps as a whole to machine learning models, because machine learning models aren't just code, and they're not just code assets. Now, there's certainly parts of the DevOps cycle we can apply to ML. So all the aspects of building the model, training the model, deploying the model, dealing with all the various different iterations of the model, model versioning, model deployment, any IT operations considerations, so containerizing, deploying onto the cloud, we can use the full vast scope of things that we have done for DevOps for ML. But machine learning models are highly dependent on data. And because of that, we have to manage and monitor the things that are data dependent, that therefore impose all these new requirements on machine learning model operations management, the MLOps space that is not specific to DevOps.
Right. And that's why we have this image here, because we want to say, yes, you can do some of this stuff, but there's new things that are introduced, and they're just as important, and you need to make sure that you're thinking about this and getting it in place. So we have things like model governance, model versioning, model discovery, model transparency as well. This doesn't just include, what model am I using, because some are more transparent than others, decision trees versus neural nets, but also where's the data coming from? How often was that cleansed? How often, is new data coming in general? And then we have model security and model versioning as well. All of these are really important and encompass this ML ops idea.
Mm-hmm. And so we have some concepts that are sort of unique, I guess, to the world of machine learning, which is the idea of model drift. Over time, models that may have one level of precision and accuracy start showing lower levels of precision and accuracy, because worldwide, the real world data is changing, or something has changed in the model. The training data is not mapping up against that. We also have this idea of data drift. Maybe the kinds of data we're working with have changed over time. I think these changes that have happened in the world very recently are indications that our assumptions for our models might not always be the same.
Right.
Financial assumptions,
healthcare assumptions.
Exactly. The assumptions that the insurance industry is making now about business continuity insurance, I bet you a lot of those models are changing right now. So, that changes models. And therefore, we have this idea of data provenance, which is, to what extent have I built these models depending on this data? And if that data changes, do I have visibility into what models that maybe I might not even expected that a model that I built depended on that training data for something else,
Mm-hmm.
and because of that, data is changing. So this has introduced really this whole world of ML ops that is much broader than this world of DevOps. It also includes model discovery. Especially if you're using models that you have not built yourself, it's important to have these measures so that you can provide visibility into those models and also a little bit of transparency. So we can move ourselves to the next slide. Let's talk about our report.
Yes. So as Seth mentioned, we recently produced a report at Cognilytica on machine learning operations. And with this report, we found some, pretty interesting key findings. As we mentioned earlier, this is a very nascent market. And in 2019, the market was at about $350 million. But over the next few years, we're predicting that this is going to very rapidly expand. And by 2025, the market will be almost $4 billion. So you can see in just a few short years, people are going to really care about this. They are going to, it's going to become really important for their organization, especially as they go from building to consuming models. How is that going to shift things?
The other thing is we expect there's about 20 vendors we mentioned in this report. They're all coming at it from different perspectives. As I mentioned, there's a bunch of folks from the DevOps world moving into ML. There's a bunch of folks from the operations and management work going into ML Ops. And there's folks who have kind of been in this universe of producing and managing models for many years, sort of in this space. And we expect that the number of vendors to grow significantly over time as people realize sort of the opportunity in the space. But that being said, this is a great opportunity for companies like Modzy to bring solutions into this space as companies are learning and figuring out the best practices. There's certainly no incumbent leader here. And one of the interesting things about this space is that the cloud vendors that you might expect to be dominant in this space really aren't, because a lot of the aspects of ML operations have to do with deployment on a whole bunch of different systems and hybrid cloud and data management, which is not necessarily the provenance of a sole single platform vendor. So there's a lot of opportunities for these more platform neutral vendors that can span the full life cycle, if you will, of ML Ops.
Right. And as Ron mentioned, in this report, we covered a number of companies, about 20, who are working on ML Ops tools for organizations and governments alike. And they don't all come at it from the same perspective. So you need to look and evaluate each tool and see what's important to you. But one of the companies that we profiled in the report was Modzy. So now we'll turn this over to Seth so that he can explain more about Modzy and why it's important for you to be thinking about ML Ops right now.
Kathleen, Ron, thank you both again. I feel like I learn something new every time we have a chance to talk. It was just great to get that overview. So, with regards to Modzy and what we really wanted to talk about today, I'll kind of shift the focus to talking about model retraining as one aspect of the MLOps pipeline that often doesn't get a lot of attention. So as Ron and Kathleen were mentioning, there's a lot of growing needs to improve the way we take models that get built and deployed on someone's laptop and move them into a production environment for all kinds of different organizations. The creation of those models has a lot of sophistication around it. There's a lot of great tools out there for doing that. But what we've discovered is that getting those models into a production state and then maintaining them at the level of performance they need to be maintained at is actually kind of difficult to do. And actually, if you can move to the next slide, Kirsten, I'll use this as a chance to kind of talk about this. So we see the MLOps pipeline looking as kind of a cyclical process after the training portion of AI. So with data scientists and machine learning engineers doing their magic, a model emerges based on a bunch of historical data, some cool open source technology, and a lot of hours of hard work. At that point, as we move through this pipeline, we get to a point where this model is deployed in production and it's being monitored. But the concept of model drift and data drift means that these models have a shelf life. There's a maximum amount of time for most models at which they're going to perform at their peak capacity. And after that, you really have to evaluate how that model's doing. As one way I like to think about it, the world is changing around all of us. Ron, Kathleen, you guys stole my analogy. I was going to use the coronavirus analogy of a good example of data drift and actually concept drift to an extent too. But if you're a utility company, you had a pretty good expectation of what, Wednesday, the 17th of March or 18th of March probably looked like 3 months ago. But as 90% of American workers are probably working from home today, the power grid is looking a lot different than you would have expected. So the models you may have had in place for power distribution, generation, matching supply and demand, probably way out of whack. And it's, I think, a testament to our experts in that field that we're all connected here on the internet today. But as you look to explore how do we get over this hurdle, I think it's important to recognize a retraining loop has to exist for any models that are actually going to be used in a real production state. And we see 3 different scenarios in which you may be considering retraining as part of the sort of enterprise deployment of AI in your organization. So in some cases, you may have a need, a use case, a business need that can be met with a purely commercial solution. So if you're in, say, retail, you may have a need for sort of automated security monitoring. You want to reduce shrinkage by identifying and then ideally preventing shoplifting and theft. As a retailer, it may not make sense for you to become your own security company and build a data science team to build a custom model that identifies and detects theft. Instead, using a commercial solution actually makes a lot of sense. And for commercial solutions that exist to do this, and there's quite a few, it's probably a good idea to pick one that's going to work with the kind of data that you have, and then rely on that vendor to provide the kinds of improvements over time that that model needs to keep doing its job well. So in that case, the retraining is really in the hands of the vendor and allows you as a technologist, CIO, CTO to really focus on your core business and not get too distracted. But in a lot of other cases, you may have a really specific use case or mission that only your organization is uniquely positioned to address. So in that case, you have to build a custom model. So if you are a package delivery company, you're probably the only organization that's really best suited to create a model to predict demand and move your trucks around efficiently to deliver all the packages that you're managing and handling. In that case, you're probably going to go ahead and have to build your own model, develop the data set, hire data scientists and machine engineers. And one of the things we're recommending here is that as you're thinking about building these models and using machine learning in your core business and your core mission areas, to build in this retraining loop as a natural part of the production of a model. Once these models are built for the first time, that is not the end of the process, that's just the beginning. And it's really important to think forward about what happens as the world changes around us and how do we prepare the machine learning algorithms that we're using to adapt to these kinds of changes. So commercial models, that's great. You can leverage a vendor and cancel your subscription if it's not performing as you need it to. So they've taken care of it there. For fully custom models, as you're building out your pipeline, it's important to keep this model retraining in mind. But what about some sort of hybrid, something in between? Well, we see continued needs from the customers we've been serving for kind of a hybrid approach to model development. There are a lot of great commercial models that do a pretty darn good job on most data sets of a specific class or type. So this could be satellite imagery analysis. This could be security camera monitoring. This could be language translation. And so they'll do, I'll say the 80% solution, as consultants will often say, of a specific job, a specific use case. But most organizations have some uniqueness to their own data. If you're a healthcare company, the text you're working with is really specific to healthcare-related topics. If you are a private equity firm using satellite analysis to make investment predictions, you're going to be using data in a different way and looking for different answers than if you're a construction company using it to map out sites. So for these use cases, what we recommend is actually thinking about a hybrid option where you start with a commercial algorithm, a commercial out-of-the-box model, and actually leverage something called retraining to improve and enhance that model on your own data. So it gives you the opportunity to take a model that at its base is very strong and performs well. I liken it to having an undergraduate degree, so strong base education, knows its stuff pretty well, and then taking it the last mile, taking it to graduate school on your data so that it can be better suited to solve the specific needs and missions that you have in your organization. We see that as being an essential part of the ML Ops process because it ensures that those process that over time, as models are reducing their performance, as we start to detect drift, there's a built-in flow to actually improve those models over time, as well as to take commercial off-the-shelf models with very little additional work, tailor them to your specific need or use case. So Modzy's actually been building out some features to address this challenge. In particular, we're looking at providing retraining of commercial AI models, enabling them, again, to be tailored to your specific data and scenarios. So this lets you go from that 80% solution to maybe a 99% solution. For today, we're doing this with image classification, but we're looking into some other areas where this could apply as well. So with the concept of image classification, essentially you can provide your own set of data to the models that we've built already and that come from the commercial marketplace we've developed, and essentially press the retraining button to improve their performance. We've seen increases of 15% accuracy in as little as 10 to 15 minutes of retraining. So it really becomes a very cost-effective way, if you're a manager in an IT department, to get the best of both worlds, using commercial capabilities where they make sense, but also being able to tailor them to your organization. So as you're looking to scale out the way you approach machine learning apps, consider that hybrid option of commercial models with the ability to tailor them to your needs. The second thing that we've been building out that we also really recommend you look into is having live performance metrics that will allow you to monitor drift and monitor model performance in production as these models are out working with data in the real world. That's something else that we've built into Modzy that we think is going to be really useful and helpful in making sure that all those models working on critical systems, core mission functions of your business and your organizations, that those models are performing exactly as well as they need to, and that the second performance degrades to a point where it's really not doing the job anymore, you've got a notification to be able to then kick off that retraining loop. So we just want to spend a couple minutes on that topic because I think it often gets overlooked. But the more of our organizations that are using machine learning day to day for these core missions, the more of a challenge it's going to become, we think, to keep all those models in good working order as the world only changes more and more every day. Second law of thermodynamics and all. So the other topic we want to spend a little bit of time on is AI governance. And we think of model retraining as potentially one component or one aspect of governance in general, which really contains a number of other different facets. From our way of thinking, we see transparency, security, and authorization as key aspects of strong governance with respect to artificial intelligence. Now, I come from a technology background where the word governance was a four-letter word. It typically meant someone was telling me I wasn't allowed to do something that I needed to do to get my job done. And that was not always the most fun. So what's changed my mind is kind of taking a different perspective and different look at what governance can do and the benefits that it can offer. So first of all, we see the reduction in the risk associated with shadow AI as a key reason to focus on governance early on. The risk of shadow AI is essentially that different business units, line of businesses, different portions of your organizations could be making purchases, could be picking up AI capabilities that they're using for core mission functions and using them on data that maybe they shouldn't be. Maybe they're using models that have bias built in. Perhaps they're applying those models to personally identifiable data or health information where that's really not appropriate, either from an optics standpoint or truly from an ethical standpoint. The risk of these AI capabilities being misused or generating incorrect answers is really high if there's not a central way to govern and manage the quality of these models. So that's one benefit. Another is around getting better insights into usage and cost. AI in particular, more so than a lot of other standard cloud services, can be really expensive to run. If you're purchasing the equipment yourself, there's some big, heavy upfront costs. But if you're using cloud services, it's not necessarily a significant discount either if you're using these cloud services in true production use cases. So being able to have a centrally governed AI platform gives you the control to get a sense of what are those costs? How much am I spending on GPUs? How much am I spending on the P2 instances on AWS or GPU instances on Azure that are keeping these models up and running? And how do I make sure that I've got the control in place so that these capabilities don't blow up our budget? Another is around improving overall model performance through better monitoring. As these models are up in production and doing their work, being able to get a sense of how they're performing, how much data they're being used to process, what use cases they're applying to, what systems they're getting integrated into. That can be really helpful, especially begin calculating things like a return on investment. We've seen early research and early investments in AI often have a lot of excitement, but often sour pretty quickly when the leaders of these organizations, particularly in IT, but also in strategy organizations, have a hard time figuring out how to calculate ROI. And that's often because there isn't ROI in the early stages. So being able to monitor and keep track of which capabilities are actually adding value to an organization is really helpful in fighting and justifying the budget that's being put into additional AI capabilities and AI research and development and production efforts. That monitoring is really, really helpful. And finally, I think the most important part, and the reason why most of us are here, I suspect, is really just to help accelerate our team's abilities to build AI apps quickly and efficiently. And having a centralized governance structure to do that means that you can provide all the tools necessary to all the users in whatever sort of role they take in the development of AI capabilities. They each can get the capabilities they need to quickly build and deploy AI-powered applications. That means either building and deploying the models, the domain of the data scientists, machine learning engineers, integrating them into applications, typically the domain of software developers, monitoring these applications from a security standpoint, something that the CISO's organization might do. Having a centralized approach to governance means that you can figure out what each of these different personas need, give them those tools in a way that still maintains that level of security and mitigates that risk of shadow AI popping up and generating a lot of risk. So some of the things we've done within Modzy to help enable this kind of central approach towards governance includes a log first, ask questions later mindset. Everything that gets done on the Modzy platform, any models that are leveraged within Modzy's sort of inference tools, all of those functions are logged for historical review, both in log files as well as a lot of different dashboards for different personas to keep track of model consumption, data usage, system integrations, so on and so forth. Having that transparency is really important for after action reports, as well as for engineering managers to keep track of the costs and the infrastructure that's being used. Another aspect we think is pretty critical is role-based access control to really separate rights by the position and sort of mission that you serve within an organization. So developers getting really specific capabilities within the API, data scientists getting the ability to create and review models, administrators having the control to manage how much infrastructure is set aside for certain AI capabilities, again, for cost and resource management. We're really excited about some of the capabilities we've added there that we think CTOs and CIOs are going to get a lot of value out of. Another aspect that we've built into the platform is an API key-based model execution protocol. And essentially that means that every single job and AI process that's managed within Modzy gives administrators the ability to have full control over whether or not that job runs, how much infrastructure is set aside for that particular job, what data sources it's allowed to connect to, who's allowed to use that model. It provides a lot of detailed control so that you've got information at your fingertips on how is this AI being used, is it being used appropriately, effectively, and is there an action that needs to be taken for security or cost-based change. We built in approval flows for the deployment of new models to make sure that all of the models that your organizations are building and producing for production use cases have the ability to go through a detailed review to make sure that whoever's going to be responsible for approving these models for production use cases has a chance to check this model out, evaluate it for bias, ensure that the data sets that were used were the appropriate data sets to use for this particular model, make sure that the technical approaches that were taken are sort of the most up-to-date available. All of this can be done within a governance process that you can define within your organization in a way that fits the way your organization sort of IT and research and business units all work together. We've also built in a lot of model management tools, both by model and version. So you can keep track of all the models and all the versions deployed within your environment, and keep track of all of the details about each one of those in a very detailed biographical way. So every piece of information that this model used to create its outputs, who created the model, how it was developed, all that information is included as metadata along with these models to, again, help ensure that there's a level of transparency and trust in these AI capabilities. And then finally, we think it's really important to prepare AI capabilities for the level of security that's needed for truly high-end missions. So we've made sure that Modzy's built to be compliant with both FISMA and FedRAMP standards. So this enables this platform to be able to run on on-prem systems, VMs, private, public, hybrid clouds, wherever they need to run and whatever type of data they need to be run on. We think it's really important that you sort of are thinking ahead about what kinds of AI capabilities are going to be needed at different levels of security and on different kinds of data. So that's everything I wanted to cover today around retraining and governance. I really appreciate the time, and at this point, we'd love to just spend a few minutes answering some questions around this process. So Kirsten, did we have a few questions we wanted to kick off with?
Yeah, so why don't we start with a question for Ron and Kathleen. You know, in kind of seeing what you've seen in terms of the research that you did in conjunction with the ML Ops market report, how are you seeing companies go at, you know, building governance and retraining into the products and solutions they're building? Are you seeing a lot of this pop up in how companies are starting to think about their products, or is it something that's still sort of an emerging area? Oh, you're still muted.
Thank you very much. Just wanted to keep you, that was keep you in suspense, because I think we had a suspenseful answer for you on that. So how are companies dealing with governance now, sort of with or without tooling? I don't know if, also just how are these vendors dealing with governance? Well, here's the interesting thing about machine learning models is that as we're becoming more and more dependent on them, as companies are starting to use these models for more important activities, people ask these questions like, oh, how should I know to trust this model? How do I know who's been in charge of training this model? How do I know who is in charge of managing the training data set, selecting the data set, selecting the hyperparameters that are being used for it? These are things that people are starting to almost ad hoc document and audit. But of course, what's needed is not an ad hoc way of doing it.
Right.
We need a systematic way of doing it, because as we start depending on these models, we need a system to do the more auditing, logging, tracking, approval of changes to any of these configurations. And that's what we're starting to see become more part of these products and solutions. Yeah.
Right. And I think that, you know, like Ron said, it can't be ad hoc, because, you know, one team can store it in one location, one team can store it in another. Maybe you don't have access to that. So you need to have a uniform approach so that everybody is on the same page. And that's why we're starting to see these tools begin to take off, because I think that, you know, previously companies weren't thinking about this, and now they're realizing, hey, we need to have an approach.
I think the same thing with retraining. It's like, you know, I think people are becoming aware that they need to have a retraining pipeline. That's the terminology that folks are being aware of, and that not just dealing with the training, but this retraining. And so a part of it, they're without these specific solutions, they're retrofitting existing DevOps methodologies and tools with the retraining pipeline. But clearly, that's not going to be the long-term solution, is to have something that's more purpose-built, because what you need to know is how specific data impacts the model and how that model performance is changing over time, which would then require retraining. But to do retraining, you need to have new training data, right? And that training data needs to be clean. It's like you need to have that whole process. Then you need to do data cleansing and do all that sort of stuff. So that way you don't make the model worse over time. The purpose of model retraining should be to
improve.
Exactly.
Right.
Exactly. Hope that answered your question.
Great, thank you. And so we have another one. I think this one can be directed more to Seth. In going back to the architecture chart that we just looked at, what do you see as being the most difficult part of the pipeline?
Yeah, it's a good question. I think it has to do with evaluating the environment in which you need to deploy AI capabilities, and then figuring out how to connect all the dots. There's so many tools involved in modern data management systems, so many pieces of technology that CDOs, CIOs, and CTOs are purchasing and have to manage. I think the most complicated part is figuring out how to connect all these things together. So, I would say having an approach that can leverage an open architecture, take advantage of the most common standards. API-based approaches, I think, are really helpful because it makes it a little bit easier to connect all the pieces together. And then recognizing whether or not you're going to need sort of dev, test, and production-based versions of all these systems. That can add a lot of cost and complexity. So especially for scenarios where you're going to be using AI capabilities on sensitive data, whatever that might be, if it's customer data, if it's citizen data, you really have to think about what are the implications of using AI on that data and what environment in which it's appropriate to use those capabilities from a security standpoint. Once you've done that work to figure out sort of the operational environment and what tools and technologies have to get connected together, almost the enterprise architecture part of things, then the actual implementation doesn't have to be that complicated. But once you've sort of committed to a specific implementation and information architecture, enterprise architecture strategy, it becomes a lot harder to undo that later on down the road if you realize you've run into a problem or are using data on a system it's not authorized for. That starts to cost a lot more money to have to fix it after the fact, rather than having a good plan in place and selecting technologies that enable good interconnectivity.
Mm-hmm. Yeah, to jump in here as well, we do here at Cognilytica, we spend a lot of time on case studies and best practices. We do a lot of documentation of what's out there. And what we find most of the time, like 8 or 9 times out of 10, is that a lot of it comes down to data quality and data, all these other aspects of data.
Or 10 times out of 10.
Yeah, maybe 10 times. Maybe I'm underestimating. But yeah, I mean, it all comes down to, like, are you using old data? Are you using data that doesn't actually have the relevant features that you need to train the set?
That doesn't represent the real world.
Right. Are you using data that is incomplete in some way and you need to add some completion to it?
Or quality data.
Right. And then are you using this data for really important decisions? Maybe you're using this data to help with allocation of resources, allocation of people, maybe governmental decisions at the federal, local, county level. These are things to be aware of. And I think what we're finding is that these data quality issues will always make their way even back into retraining, because if you're trying to do this continuous training, then you actually need to be doing continuous quality. And if you think, well, I'm going to spend 3 months cleaning my data and I'll be done, well, guess what? If you're going to be retraining, can you afford to continue to spend that time on data quality? And if not, then you need to actually, it's really more about process, what's your process for going about data quality and data cleansing?
I think that's a good way to think about it. I mean, in our experience, oftentimes sort of the human processes, the human aspects of data management and AI are more complicated to solve than some of the technical ones. So having good processes in place that people sort of have a good understanding of and a good framework for making decisions makes things a million times easier. And often once you solve those, then the engineering challenges kind of work themselves out.
So here's another question for Seth. Detecting model drift can be difficult. Does Modzy provide any tools or monitoring capabilities?
Yes. Yeah, we've got a couple of different capabilities. Model drift is complicated differentiate it in a couple ways, in that there are different kinds of things, different ways to detect different kinds of drift. So one of the hardest types of drift to detect is drift that requires human input to identify. So that really means that there has to be a human in the loop involved in identifying mistaken classifications, mistaken outputs from these models. So at present, that's not something that we've got built into the platform. It's something actually our ModZ Labs team is researching, some of the mechanisms we can put in place to help end users who may be using outputs from these models sort of flag classifications and predictions that aren't right. And that really helps with concept drift. But we do have other capabilities that we built into the platform to help monitor data drift. So as the input data is actually changing statistically in a statistical measurable way over time, we can help identify the changes in that model's performance against that changing data, as well as within the model retraining tools that we have, allowing our customers to be able to submit new sets of labeled data, of their own data, to actually calculate performance metrics against their own internal data sets. So with a little bit of elbow grease from a human being providing those improved labels, we can also provide basically drift calculations and changes in performance metrics that way as well.
And one more for Seth, sort of on a similar piece. Can you speak a little bit about Modzy's approach with managing bias and training data? There's some open source tools that do bias detection, but curious to hear more about how Modzy handles bias in data and how that may impact model performance.
Yeah, that's another excellent question. Clearly, someone who's been down this path before, and I hope you're doing okay, because it's not easy to handle and manage. We take bias really seriously for a couple of reasons. One, biased models are just not as good. If you have a heavily biased model, it will not perform as well generally than a model that is as bias-free as you can get within the realm of possibility. The second reason is from an ethical standpoint, particularly models that are dealing with human data, whether that's human faces, PII, PHI. Bias built into these models can have some really catastrophic impacts on human life. And even the implication of those impacts can be really detrimental to a business or organization that's using machine learning models to make decisions about human beings. All that is to say, it's really important to take bias seriously and make sure that you're providing ways to get around that. So we look at it from a couple of different perspectives. One is around the transparency of the model training approach for each and every model within Modzy. So we essentially require a detailed listing of all the data sets that were actually used in training. One of the best and most effective ways to get around model bias is to have really a wide and diverse set of data. So within each of the models that are added to the platform, all the commercial models have a really detailed, and can think of it as a report card of here's all the model, here are all the data sources that were used to create this model. Feel free to check them out yourselves. We often will actually do statistical analyses of the data that's being used for these models as well, and doing classification metrics to figure out what percentage of each of these classes can be found within these data sets to help make sure that we've got a really good, diverse set of data. And for models you're developing inside your organization, you can essentially require that level of transparency for each of the models that are being added and deployed into the environment, so that anyone who's considering using one of these models in production has that full transparent point of view on the sources and origins of these models. The second is really in being able to actually test the outputs of these models against a diverse set of data. So for all the models, the commercial models that are available within the Modzy marketplace, we're testing these models against a lot of varied data sets in order to figure out what the realistic real-world performance metrics of these models might be. So with the ability to essentially put in your own labeled data and test these models out, you can evaluate their relative performance against more diverse sets of data. So I think without a single silver bullet to solve that problem, it's really about transparency, communication, and some forward thinking on the part of both engineering managers as well as data scientists to make sure that the features that are being used to make decisions in a model, are as sort of bias-free and resistant to bias as possible.
Yeah, and to add a little bit on that, I mean, the thing about bias, and I think the most important thing to remember in general about what we're talking about here, machine learning, and that machine learning is we're trying to basically create some system for basically making predictions from data, learning from data, right? That at the end of the day, that's what we're trying to do. We have data, and instead of basically programming a solution with rules and with programs and flows and things like that, we're going to try to get the system to derive some sort of learning from that data. That's the whole purpose of machine learning, is to derive that learning from data. And of course, you can derive that learning from good data, and you can derive that learning from bad data. And the whole point of bias is that the bias that's in the system would be that if you're trying to get an outcome from the learning, that is you're trying to make outcomes on things like loan decisions or other applications, you want to use that with as much real information as possible. And these aspects of bias are, of course, when the model is being skewed by things that should not be real primary decision factors. Mm-hmm. So the things when you're doing a bias analysis, it has to do with like, well, what would you expect in the outcomes of your data if it basically was a fully representational data set? So if you're granting loans and you say, well, what would be the ideal model? The ideal model would be like, people with this sort of credit risk should not be getting loans, and people with this sort of credit risk should be getting, maybe greater credit scores. And then you can basically map that and say, well, ideally that should be the same based on different factors, different socioeconomic factors, whatever the factors are that are not maybe relevant to the score. And you can compare the performance of the model against your ideal. Of course, knowing that the real world is never ideal, because there may be actual correlations between people that say live in one geographic region may not be making as much as people who live in New York City. Average salaries will be much higher than people who live in Lexington, Kentucky. That's just the way it is. So there may be correlations between things that you may or may not expect there to be correlations, geographic location compared to credit limits, for example, which was the problem that the Apple Card got into, with a whole other podcast that we did, by the way, at AI Today, if you want to listen about that. But the point is that when you're looking at bias data sets, I think part of where tools like Modzy can be helpful is looking at measures of accuracy and looking at performance measures, and then comparing that if you're a data scientist or is creating these other measures and comparing against them to know if the data set has some what we call informational bias that is not related to these other aspects. Because, by the way, the problem with machine learning is that term bias is actually used in 3 different ways.
Right.
Right? There's bias in deep learning, which is the neural net bias, which has to do with bias, weights and biases, which are completely different. And of course, there's the whole bias variance trade-off, which is a whole other definition of bias. That's nothing to do with this. So I'm assuming that the question has to do with what's called informational bias, which has to do with the something that's in the data itself. So I know it's kind of a long-winded answer there, but hopefully that provides some context.
Awesome. And I think we have time for maybe one more question. Seth, could you explain a little bit about the concept of shadow AI and how implementing good practices, or using tools that have features built in to help manage governance and have retraining built into the solution, how these kind of defend against some of the risks associated with shadow AI?
Yeah, shadow AI is one of those areas where it's a double-edged sword. I think it's coming from a good place. Essentially, shadow AI is when a business unit or a mission unit is just trying to find the best tool to get their job done as quickly and efficiently as possible. It comes from an incredibly good place. And I think good CTOs recognize the intent behind these purchases and acquisitions and development efforts to create new machine learning capabilities. And I think it's important to actually encourage that kind of mindset, encourage that kind of free-spiritedness in the creation of new technology. Ultimately, it means that your organization is probably moving in the right direction and moving at the speed it needs to move at to adapt to the changing world. But the downside and the risk is that folks who don't really have the expertise to be making decisions about what AI capabilities should be used, what security considerations should we be addressing, are making those decisions for your organization, and you as a C blank O don't really have the knowledge to know where that's happening, when that's happening. So when I think about shadow AI, I think it's about providing access to the tools and technologies that these business units and program managers and missions need to do their job well, making it really easy for them to choose the most secure option, to choose the better governed capability. And typically, I've seen this within the companies I've worked in. When you make good tools available to smart people, they'll use them. They prefer to not have to do everything themselves and bootstrap everything. It's typically just the fact that they can't get access to the tools and capabilities that they need, and so they go out and find some SaaS provider that will do predictive analytics on whatever financial data set they're working with, without having thought through the impact of sharing their proprietary financial data with this SaaS company without reading all the fine print about how that data is then going to be used in some other way. So we think that the use of something like Modzy can really help a CTO get a handle on shadow AI by balancing the need to give AI capabilities to these different units and mission areas, making it easy for them to get the stuff that they need to do their jobs well, but doing so within an environment that gives those technology organizations control to make sure that things are being done in a secure way, in a safe way, in an ethical way. We think that's really important. So that's kind of the mindset that I've taken on that topic. Kathleen, Ron, what is your take, or how have you seen sort of shadow AI transform over the past couple of years? Has that become more of a concern to your customers?
It's interesting as to whether or not it would be a concern or a benefit. It's kind of interesting. I mean, obviously there's a problem with people building applications and functionality that's unsecured and being repetitive and being redundant, and clearly you don't want that, right? So hopefully, well, actually the most understated part of the ML Ops platform that I think might be the most interesting is the whole model discovery, model registry thing, which is that one way to sort of, I don't say combat, but one way to prevent the runaway shadow AI, people basically building the same models that kind of do the same thing, or like duplicating it, at worst, duplicating data cleansing efforts, because that's bad. So it would be the use of more things like model registries and model catalogs and things like that.
Right, because data cleansing can take a lot of time and resources and money. So, to clean that data twice is not something that organizations should be doing, especially, assuming that it's a large quantity of data.
But that being said, there's going to be a lot more shadow AI, and I can tell you why. First of all, if you look at things like the Microsoft platform, they're putting the ability to create models into Excel. You will soon be able to highlight a bunch of cells and basically say, build me a predictive model, and it'll either be on your laptop or go up to Azure Cloud. Now basically anybody with a spreadsheet can basically build a model, or any of the power tools there. You have everything that's happening with the robotic process automation space. These are RPA tools, which are not really AI, they're just workflow automation, but they're embedding AI capabilities inside of them. And now anybody who's not really a developer, who's some line of business person, can build a process flow, and that can enable or use some model that somebody else built, and now you have to manage that stuff. So I think there's just going to be a vast proliferation of shadow AI everywhere. Yeah. Hope that answered the question.
No, that was exactly, that's really interesting to hear, and that's kind of what we've seen as well. Well, I think that about wraps us up for today. I just want to thank Ron and Kathleen once again for having you join us today for the conversation, the great insights and ideas. It's always a lot of fun to talk about this stuff with you both. Again, for those of you who have not checked it out, please take a look at their ML Ops report. I think you'll find a lot of good insights in there, and some topics we've definitely covered today, but in a bit more detail. If you have other questions on Modzy, please reach out. We'd love to talk more about some of the specific questions that a few of you raised. related to the different features we offer, some of the things we're doing around model retraining and governance. You can check us out at modzy.com. Whole lot of detail there, both technical as well as for business users. And we're also on LinkedIn and Twitter. So if you're interested in hearing more about what we have going on, please connect with us. We'd be delighted to have another conversation.